Hi everyone, this is just a quick video showing off my virtual texture renderer. It's really super early stages, and the only reason I'm showing it off is people keep asking me how it's going and what stage I'm up to. So this is just sort of to show where I'm at and document things that I've done and things I want to do with this. You can find online way better explanation of a virtual texture than I can give, but I'll just give a quick one. The basic idea is that we figure out what textures are needed in any given scene, and then stream them in, and then we use a lookup texture to so then the GPU can look into our texture pages and use those textures as if it was one big texture. I know that's a horrible explanation, but I'll walk you through it a bit more and hopefully it'll make sense. So the idea, if we just move the camera around a bit, so down the bottom left here, this is rendering the scene with a shader that will figure out what textures we need. I know it's bad contrast, but it's not important that you see it well. Then, so we take this scene, then we process it on the CPU to figure out what texture pages are needed. And then over here, once we have that list of texture pages that we need, we load in these pages here. Then we create a remap texture, which is this texture here, which doesn't really make sense to the eye, but this is a texture that's wrapped over the whole world. So when the shader goes to render this scene, it'll look in here, and so like this point, if you decode this here, will then point to a page in this texture here. So if we move the camera around a little bit, we should see it updating. Actually, I'll get rid of these debug views. So you can see here it's we need 93 pages to render this scene, and we need to load 0 at the moment. But if I move the camera a little bit, you'll see this number here going down as it's loading in these textures. I should just say too, if we don't have a texture, I render it with this invalid blue and red textures just to show that we need to load the texture. And there you can see it's loaded again. So let's fly over here and look at this. So we'll see all these textures of this crate. These crates should load in. Can show the you can see them here coming in. So using this texture here, we figured out these are the textures that we need to load. But this is exactly what we can see. So what happens if I fly around the other side of these crates? You can see none of those textures were loaded because they couldn't be seen. You'll see them come back in. But if we fly back here, see it's pushed out some of these textures. This would be pretty easy to fix. What's going on is that I'm not prioritizing any of these textures here. Once we determine that it's a page can't be seen, it's just flagged as empty, and when we're loading in, it just finds the first empty space. Adding some sort of priority here to, time since texture was used, or any sort of other scheme like that should fix that up. The other thing I should point out, this looks like a really bad mess. So these stripes down here are due to the UVs that I've used to unwrap this world are just really bad and quick. I didn't want to spend too much time on that. the size of the mega texture is only 8K by 8K. Again, that was just for speed, just so I had some test data to play with. I wasn't worried about it looking too pretty. And the other reason why you can see pixels here is that I haven't implemented bilinear filtering. That's because it would, when we sample from each page here, we would cross over a boundary and you'd see like pixels coming in that shouldn't be there. That's one thing I want to fix. Looks like a lot of other people solve that just by having a bit of a guard around each page. Yeah, so the other thing is, if we pull way back here so we can see the whole world, well, a big chunk of it, you can see up here that we need 464 pages to render this scene. Trouble is, we can only have this here is the texture cache is 4K by 4K, and each texture page is 256 by 256 pixels. So that means we can only load 256 tiles, or 256 pages, and I use one here for the invalid texture anyway. So this whole scene can't fit in this texture cache, and the reason for that is that it is easy. I just haven't implemented mipmapping yet, so it's loading in this like texture page at the same resolution as this texture page, way off in the distance. So that's definitely the next thing I want to look at. The other big thing that I need to implement is the reading back of this texture is really slow, because I'm using DirectX 9. This texture is generated on the GPU, but then we have to transfer it back over the bus to in memory that the CPU can read from, because then we read through these textures, this render buffer, and figure out what pages we need. As far as I can tell with DirectX 9, there's no way to not stall the GPU and the CPU while this is happening. Looks like you can easily fix it in OpenGL and DirectX 10 and 11. I'm probably going to port this to DirectX 11 to solve this problem. I've already done most of the work to do that. I just need to finish it off. The other thing you could do would be to generate all this offline, so you could for each different region you could have which textures are loaded, but I like the idea of generating it on the fly. It means if the scene's dynamic and stuff like that, it should just work nicely. Although when you turn slightly, you'll see here like these textures aren't loaded. Easy fix to that would be to make this readback buffer's field of view slightly wider, so it would load those textures in before they're needed. Anyway, that's a quick demo of this. Obviously there's still a lot of work to do, but it's been a lot of fun. Hopefully be able to show you guys more soon. Thanks for watching.